So today, that's what our lesson will be over, is inductive reasoning, which we will use throughout the course. So it's important for us to learn now. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. Again, inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. It's usually like when you use patterns. Patterns are usually indications that it's inductive reasoning. Alright, so we have another vocabulary word is conjecture. A conjecture is another word for a conclusion. So it's a statement that you believe to be true based on inductive reasoning. Again, just to repeat, conjecture is another word for conclusion. So I would put conclusion next to conjecture so I can remember. And it's just a statement that you believe to be true based on inductive reasoning. So for example, let's say Miss General wears green every day. Something green every day. So if you see me in green every day, your conclusion is going to be that what? Miss General must like the color green. That is a conjecture that Miss General's favorite color is green. Okay, so when you're doing inductive reasoning, first I want you to look for a pattern. Two, make a conjecture. And three, prove the conjecture. You need to prove it true or false. Okay? Just because you think my favorite color is green because I wear green all the time, that might not be the reason I wear green all the time. Maybe my parent died and his favorite color was green, so I wear green in memory of him. So that's what I mean by proving your conjecture true or false. A counterexample. A counterexample. To show a conjecture is false, you have to find one example in which the conjecture is not true. So if you say, Miss General wears green every day, but on September 21st, I wore all black. That would be a counterexample because you said every day, and September 21st proves you wrong. That's a counterexample. And we'll talk more about counterexamples later. And you must prove a conjecture true or false. So you can't just make a conjecture and not say, okay, yes, this is always true, or if it's false. And if it's false one time, it's automatically false. Again, just so you can remember, if you weren't able to write what a counterexample was, a counterexample is to show a conjecture is false. You have to find one example in which the conjecture is not true for it to be false. Alright, you are going to do the little half sheet of paper I gave you, and we'll go over it tomorrow. Make sure you tell me if the conjectures are valid or invalid. And if you tell me it's invalid, make sure you show me a counter example. Thank you.